Okay, so I don't know if we'll have time tomorrow to work on all these problems, so I'm just going to go through 1, 2, 3, and 4 in terms of mixed integration techniques. One of them can be solved using U sub, one of them can be solved using algebraic manipulation, and then the other will require either partial fraction decomposition or IBP. So, there are a couple of things that I would do first. The first thing that I like to do is think about, can I use U sub? So for example, for 1a here, I know that if I'm going to use U sub or try and use U sub, that my U is going to be x squared plus 1. That means that my du is going to be 2x, and I could see that, hey, this is going to cancel out whenever I do u being x squared plus 1, du being 2x dx, which gives me the integral of sine of u du. And then, of course, we know that anti is cosine of u plus c, negative cosine of x squared plus 1 plus c. Now, looking at 1b here, I have a power raised to the negative 1. So I am going to rewrite that as a fraction here. So then I have 1 over 1 minus sine squared of x dx. Now, there are a couple of things that you guys can do next. One thing that you might be able to do is do 1 plus sine x and then 1 minus sine x. Now, the problem whenever we do this is that we can't really do partial fraction decomposition here just because we have 1 plus sine x and then 1 minus sine x. Now, that means that I can't do partial fraction decomposition, and I need to think about other techniques. Obviously, this isn't going to be IBP, so the last case scenario would probably be some sorts of algebraic manipulation. In this case, I can manipulate 1 minus sine square of x to be cosine square of x. And that is the same thing as saying secant square of x dx. And we should know our trig derivatives and trig antiderivatives. The anti of secant squared dx is going to be tangent of x plus c. Now for number 1c here, where I have 2x sine x, I think this is just your traditional IBP, right? In this one, I'm going to use tabular just because u could be 2x, 2, 0, sine. The anti of sine is negative cosine, and then the anti of negative cosine is negative sine. And that's going to give you negative 2x cosine of x plus 2 sine of x, and then don't forget about your plus c. All right, so what if we have a quadratic in the denominator? Now, with a quadratic in the denominator, there's like 3 options. You could either do u sub, you could either do completing the square, or you could use partial fraction decomposition. So if I were to think about x squared plus 4x plus 5, I can't really factor that in terms of factors of 5. That's going to give me a sum of 4. Because I can't factor this, then it's either going to be a u sub problem, or it's either going to be a completing the square problem. In this case, once again, like I said, I'm with number 1. If you could do u sub, then do u sub. So in this case, if I let u be x squared plus 4x plus 5, du is going to be 2x plus 4 dx, and then that's going to give me 2x plus 2 dx, which is going to cancel out with the x plus 2. We're left with 1/2 the integral of 1 over u du, 1/2 of ln of u plus c, 1/2 of ln of x squared plus 4x plus 5 plus c. Now, If I do u sub for 2b, I can't because my u is going to be x squared plus 5x plus 4. My du is going to be 2x plus 5, and I can't cancel that out. Another thing that you'll notice that here with this one, I probably can't use partial fraction no, not partial fraction. I really can't use completing the square here, because with completing the square, I probably want... Why can't I do that? I probably want this right here to be an even b value. But in this case, because we have x squared plus 5x plus 4, think about, okay, I could probably factor this and use partial fraction decomposition. Now, one thing that I did notice on our whiteboard activities is that you guys kind of skip this process right here in terms of rewriting the integrand in terms of a and b. I would encourage you guys to do that just so that you know where a is and where b is whenever you guys solve for a and b. So when x is equal to -1, we're going to get 3b is equal to 1, b is equal to 1/3. And then when x is equal to -4, we're going to get -3a is equal to 1, a is equal to -1/3, which means that I'm going to take out a 1/3, and then we have the integral of -1/3, no, the integral of 1. Well, yeah, 1, well, -1 over x plus 4, plus 1 over x plus 1 dx. I'll probably move the x plus 4 to be the second term. That's just my preference. Okay, why is my thing not working? Okay, so then I'll get 1/3 ln of x plus 1 minus ln of x plus 4. And usually we will ask you to condense this into one log. So I'll have 1/3 ln of x plus 1 over x plus 4 plus c. And then last one is 1 over x squared plus 4x plus 5. This one, again, I can't do factoring with x squared plus 4x plus 5. And I can't do partial fraction decomposition because I can't factor. And I can't do u sub. So my only choice here for 2c is to complete the square. After completing the square, figure out what your u is and figure out what your a is in terms of your inverse tangent. So in this case, it's going to be 1 over 1 inverse tangent of u over a. And that's going to give you inverse tangent of x plus 2 plus c. All right. Likewise, with number 3 here, what we are going to do here is think about, can I do u sub? Remember that with your u's, that it's most likely 99% of the time going to be with e. So in this case, your u is going to be x. dq is going to be 1 dx. Well, if you do that, then you're just left with u squared e to the u du, which of course still doesn't really make sense here because then it's just more integration by parts. So just do integration by parts here. Also, if you do u to be x squared, du is 2x. We can't really cancel out anything here because then you'll be with 1 over 2x u e to the root u. This just looks like a hot mess right here. So for this one, just use integration by parts. And this one is another one where you could just use tabular. And call it a day. And because everything is e to the x, I'm just going to factor out an e to the x, which gives me an x squared minus 2x plus 2 plus c. That way, if I ask you guys to find the point of inflection, you could easily find the second derivative here by using product only one time. Because if you were to do e to the x, x squared minus e to the x, 2x plus 2e to the x, you're going to have to use product here, and you're going to have to use product here, and then that's going to be a hot mess. All right, for 3b, notice how you have an x squared with e to the x squared. So probably your u is going to be an x squared. Your du is going to be a 2x, which means that we're going to have 1/2 the integral of e to the u du, 1/2 e to the u plus c, 1/2 e to the x squared plus c. And then for 3c here, notice how e and ln are cousins of each other, so they're going to cancel out, which means that you're just left with x squared, and then that is just 1/3 x to the third plus c. And then, of course, we have our lovely fractions. All right, so looking at 4, this is like your basic partial fraction decomposition problem, right? So in this case, you're going to do a x plus 1 plus b x minus 1, and then figure out what your a and b values are. I'm not going to do that, but that's what you would do with number 4. And then looking at 4b here, anytime you have one term in the denominator, always try and split up your terms. So you have x cubed over x squared plus 1 over x squared dx, which gives us the integral of x plus x to the negative 2 dx, 1/2 x squared minus x to the negative 1 plus c, and call it a day. So good old algebraic manipulation by simplifying. In this one, same thing, use u sub. U is going to be x cubed plus 1, du is going to be 3x squared. Notice how that's going to get canceled out. So now we have 1/3 1 over u du, 1/3 ln of u, 1/3 ln of x cubed plus 1 plus c. All right, so essentially, whenever you guys are looking at the best strategy, always try and use u sub. If you can't use u sub and there's no fractions, obviously, then it's probably going to be IBP. And then if it's not IBP and you have a fraction, then it's either going to be algebraic manipulation in terms of completing the square or partial fraction decomposition. Of course, these aren't all of the types that you'll see on the quiz. Like I said earlier, you will probably see absolute value, and you'll probably see quarter circles and semicircles on the quiz in terms of maybe doing geometry in terms of those problems. Then, of course, like I said, memorize your trig antiderivatives, because you'll probably see a couple of those too.